Next section, we have exponential functions. Okay, an exponential function, they're not linear, they're not quadratic. Quadratic functions have x squared. Okay. These are examples of exponential functions, and if you notice, all of your exponents here are x. That's what makes it an exponential function, is x is your exponent. Okay. They're not linear, and the reason they're not linear is because if you take things to different powers, they grow very quickly, right? If you think about it, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth, 32, 2 to the sixth, 64. You see, it's going to get really big really fast. 128. The next one would be 256. It gets really big really fast. That's the whole point of exponential. Exponential growth is kind of like an explosion of growth. Okay. So, to find the y-intercept occurs when x equals 0, right? So if y is equal to 3 to the power of 0, that means y is equal to 1. So the y-intercept is 1. Okay. And then we just try a couple of others. 3 to the 1 is 3. So if when x is 1, I get 1, 2, 3. When x is 2, y is 9. So 2, 1, 2, 3, 4, 9. Okay. Now this graph is a curve. And it curves down and eventually does this. Okay. All right. My domain. I can put in any x, right? I can put in any positive or negative number for x, and it will work. My range, however, I cannot put in any exponent that will turn a 3 into a 0. If I put in negative exponents, it turns into fractions. Like 3 to the negative 2 is 1 over 3 squared, so that's 1/9. There is not, if I put in a fractional exponent, we haven't talked about those yet, but that's the square root of 3. Still doesn't give us 0. There's nothing that I can put in as an exponent that's going to turn this 3 into a 0. So my range is y is greater than 0. And I know it's greater than because it's going up really high over here. Now, if we're going to use the graph to approximate the value of 3.7, well, our exponent is the x. So here the exponent is 0, here the exponent is 1. 3.7 is somewhere in between there. So like here maybe right about there. Would you agree? We're estimating. So we say it is approximately 2-ish. It's an estimation. It doesn't have to be exact. Just 0.7 is somewhere between 0 and 1, and when I hit somewhere between 0 and 1, I'm about at 2. Does that make sense? Okay. Okay. See, we're going to do the same thing here. We're going to graph y is 7 to the x. So if I use x is 0, I get 1. The y-intercept is 1. Noticing a pattern here? Sorry, 7 to the 1 is 7. So at 1, I'm going to make these lines here 1, just to give me more room. So at 1, I go 1, 2, 3, 4, 5, 6, 7. And then 7 squared is 49, which is, you know, up here somewhere. So as you can see, this graph is going to get really big really fast. It's really steep. Okay, my domain on an exponential is all real numbers. And my range is going to be y is greater than 0. Now sometimes you might end up with a different range if we have a function that flips it over and it gets negative. And the approximate value, so I'm doing y to the 0.5. 0.5 is a half, which is right here, and that's about 3-ish. Do you see that? So if I go to a half, I go up 1, 2, it's about 3. Actually, it's probably more like 2.9, but you know, it's an approximation, so it's not really expected to be exact. Here we have a situation where I have a fraction, 1/3 to the x. So 1/3 to the 0 is still 1. Everything to the 0 is always 1. So I'm going to do my x-axis, these are going to be 1s, but on my y-axis, these will be 1/3. Just kind of to make it easier. Okay. If I take that to a single digit, it's 1/3. So at 1, I'm going to be at 1/3. 1/3 squared is 1/9. 1/3 to the 3rd is 1/27. 1/3 to the 4th is 1/81. Do you see what's happening here? I'm getting teeny tiny little fraction pieces. And like I'm at 4, I'm almost, you know, I'm like way down here. So this exponential is getting really super small really fast. Okay. When I go into my negatives, if I do 1/3 to the -1, that's 3. If I do 1/3 to the -2, that's 9. Because the negative exponents flip the fraction over. So as my x's go negative, I'm going to get really large, and as my x's are positive, I'm going to get minuscule. So this is a backwards of the last graph. My domain is still going to be all real numbers. My range is still going to be y is greater than 0. I will never hit 0, even though I will get microscopically close to 0 as my denominator continues to increase. There's no number that's actually going to give me 0.